Hi, I'm Esther Stewart, Bedrock Geologist with the Wisconsin Geological and Natural History Survey. Thank you for listening to this digital presentation about ongoing mapping in Jefferson County, southern Wisconsin, and proposed new mapping in Bayfield County and Jefferson County. Before I begin, I'd like to acknowledge and thank the folks at Wisconsin Geological and Natural History Survey who have been a part of this mapping. It is truly a collaborative effort. In particular, Pete Shepoister managed the cartography, Carson Ames has been a huge asset to the project's sample management, Pete Chase arranged bedrock drilling and geophysical logging, and Steve Mall and Chris Headley located thousands of wells for the project. The photo on this slide shows an interval of what is probably the St. Peter Formation soon after this drill core was collected, about a week ago, in Jefferson County. We are currently wrapping up year one of what was originally a 2-year project in Jefferson County. Jefferson County is located in southeast Wisconsin and is shown in blue here on the inset map of Wisconsin. To the left is a map of Jefferson County showing the fiscal year 2019 map area and the northwest part of the county. The year one project was supposed to end in June 2020, but has been pushed back due to delays related to COVID-19 until November of this year. The year two, fiscal year 2020 project started in July. Before I describe the mapping approach and show some preliminary results, I'd like to remind folks of the objective of these projects, which is to establish the geologic framework of areas determined to be vital to the economic, social, or scientific welfare of the U.S. I appreciate your input in identifying how and where geologic mapping can address this objective. This figure shows the existing statewide bedrock geologic map of Wisconsin clipped to Jefferson County. Because almost all of the bedrock is buried beneath quaternary sediment, we rely on subsurface information to create the map. What does that information include? Well, some of the data are shown here. There's one bedrock core in the northeast part of the county, about 10 geophysical logs shown by these green squares, and 6 bedrock quarries. Most of these red triangles are in quaternary unconsolidated sediments. In addition to these data, a major task of year one was to geolocate 7,683 well construction reports to the quarter section or better. These WCRs are among the most important data sets used to make the map. Thank you to Steve Mall and Chris Headley for completing this part of the project. After the well construction reports were geolocated, we used the elevation of the top of bedrock reported in those records to interpret bedrock elevation contours shown here. Bedrock elevation was interpreted at 50-foot contour intervals for the entire county and checked against places where bedrock crops out at land surface, there aren't very many of those, and NRCS shallow soils information, as well as quarries. On this figure, the bedrock elevation contours are displayed over an interpolated bedrock elevation raster surface, shown in grayscale here. Elevations range from about 970 feet to about 400 feet above sea level. Low bedrock elevation is shown in green, while higher elevations are shown in red. The Ancestral Rock River is a deep bedrock valley that cuts across the southern part of the county. The bedrock elevation surface is used to interpret depth to bedrock by subtracting bedrock elevation from land surface elevation. This image shows a preliminary depth to bedrock surface. Dark brown here is between 0 to 20 feet below land surface. Peach, this color, and here is between 21 and 50 feet below land surface, and bedrock depths are likely 400 feet or greater within the Ancestral Rock River Bedrock Valley. After completing the bedrock elevation and depth to bedrock interpretation, the next step is to draw contacts for the different bedrock units. For Jefferson County, we are mapping the Sinope Group Dolostone and Cell Group, that's the St. Peter's Formation sandstones and shales, the Prairie du Chien Group Dolostone, Trempealeau Group and Tunnel City Group Cambrian-aged sandstones, and the Waterloo Quartzite, that's Precambrian. The Year 1 map area is shown here in the northwest part of the county. And this figure here shows the preliminary bedrock contacts and a few bedrock fold axes shown in these thick black lines. The Sinope Group Dolostone, in this beige color, is mostly present in the east and in the south part of the Year 1 map area. The St. Peter here and Prairie du Chien group are present across much of the map area, while the Waterloo Quartzite, shown in purple, and Cambrian sandstones, shown in green and brown, are present to the northwest. One of the most interesting results from earlier mapping in neighboring Dodge County, here, was the identification of bedrock folds. Folds were mapped by creating a map of the elevation of the base of the Sinope Group Dolostone. For the Jefferson County mapping, we have extended the base Sinope elevation surface from Dodge County south into Jefferson. As part of a separate project, we also extended the surface north into Fond du Lac County. This figure shows the map of the elevation of the base Sinope group. Higher elevations are shown in hot colors, while lower elevations are shown in cool colors. In general, the surface slopes from west to east into the Michigan Basin. The subcrop extent of the Sinope group is shown by this thin, black, squiggly line. The Sinope group is present beneath unconsolidated material to the east of this line. Undulations in the surface are traced in the thick black lines and define low amplitude folds in the base of the Sinope group. In the recent Dodge County project, and just recently for Jefferson County, we collected new bedrock drill core. The Slinger core was collected in Dodge County over the Beaver Dam anticline. We just finished collecting the Mankowski core in Jefferson County near a fold axis. In both locations, there is evidence for Paleozoic deformation that resulted in uplift and erosion of the Prairie du Chien group dolostone. The St. Peter Formation sandstone cuts down to the lower Trempealeau group, and the Reedstown is well developed. Vertical fractures that may or may not be mineralized are present in both drill core. This section of the Mankowski core is from an interval of breccia, probably within the St. Peter Formation. This section of the Slinger core shows gray, sulfide mineralized fractures cross-cutting white sandstone of the Cambrian Elk Mound group. One of the ways we have been applying STATEMAP-supported geologic mapping in eastern Wisconsin is to use the mapping to help assess the risk of arsenic detection in groundwater wells. Initially, we noticed a correlation between high rates of arsenic detection and proximity to the Beaver Dam anticline, here, a large structure that runs through Dodge County. Eventually, we began trying to quantify and model possible parameters that could lead to arsenic being released into groundwater wells more regionally. We used a method called binary logistic regression to assess the potential explanatory variables that might lead to predicting arsenic detection. The method requires yes-no results, and in this case, a yes result is defined as when a well has been tested yields an arsenic concentration of 2 micrograms per liter or higher. A no result is when there is 2 micrograms per liter of arsenic or less. For reference, the EPA limit is 10 micrograms per liter, so these are pretty low values. We compiled over 300 WDNR well analyses from across Fond du Lac and Dodge counties. This is Fond du Lac, this is Dodge County. Gave them yes/no results and used existing mapping in the counties to identify folds and calculate distances between folds and arsenic analysis sites. We tested 6 potential variables and found 3 yielded statistically significant predictors for detecting arsenic. Those are listed here. The 3 were proximity to mapped folds, the casing depth of the well minus the depth to bedrock, and if the well is open to the St. Peter Formation. We believe the first 2 variables cause the rocks to become more oxidized, leading to a change in arsenic host from sulfide to hydroxide, and so the wells that have a hydroxide arsenic host end up having different, and in this case, higher probabilities of releasing arsenic within the well borehole. We can apply the model to any well in these counties where we know depth to bedrock, casing depth, and location, and the model will yield a probability of detecting arsenic based on the well characteristics. And we are testing this approach as part of a UW Water Resource Institute funded project. This approach could be used on thousands of untested wells in these counties to assess risk. Ultimately, we hope this will help communities understand good well construction practices and what they can do to minimize risk. We also believe it demonstrates the value of high-quality bedrock geologic mapping. In the next few slides, I will present 2 proposed areas for fiscal year 2021. The first area I'd like to propose is extending the Jefferson County project into a 3rd year. This will allow us some flexibility working around travel and other restrictions or delays related to COVID-19. It will also allow us to collect an additional drill core, which is critical to evaluating some of the hypotheses we are developing related to the timing and style of Paleozoic folding and its impact on fracturing, mineralization, and Paleozoic sedimentary facies. We would also like to work with hydrogeologists at WGNHS to start developing a hydrostratigraphic section that would be published as part of the map. We believe incorporating hydrostratigraphy would improve the practical utility of bedrock maps. The second area I'd like to propose for fiscal year 2021 is Bayfield County. Bedrock related to the 1 billion-year-old mid-continent rift is exposed along the Lake Superior shoreline and riverbanks. The survey also has a significant collection of drill cores from this area. The bedrock includes volcanic basaltic lavas that flowed from fissures and shield volcanoes a billion years ago as the mid-continent rift started tearing Proto-North America apart. Rifting ultimately failed, and the lavas were overlain by a thick pile of sandstone, conglomerate, and shale. The age of these sedimentary rocks is poorly constrained, but probably older than 900 million years. These sediments are fascinating because they preserve evidence for microbial life that probably lived on land before the Cambrian explosion of animal life. These photos show microbial sedimentary structures that formed due to binding of sediment by microbial mats some 900 to 1 billion years ago. These include cracks in microbially bound sandstone, here, here, and ripped up clasts of sandstone, here, that were held together by As part of a previous project, I described some of the drill core from Bayfield County. The image on the right, here, is an example of what that drill core looks like, while the image on the left shows the lithofacies and significant stratigraphic surfaces that were interpreted as part of that study. As part of the proposed Bayfield County STATEMAP project, I hope to complete the description of these drill core. My goal is to identify lithofacies and construct a stratigraphic framework for these rocks. Developing a stratigraphic framework and constraining lithofacies stacking patterns would improve our ability to predict physical properties of the rocks away from wells. This would be useful for understanding big picture science questions like, were these rocks really some of the oldest lake deposits with eukaryotic fossils, or were they actually deposited in an ocean or sea? More importantly, though, the ability to better characterize physical properties of the rocks has practical application, for example, for managing groundwater resources or understanding the potential for carbon sequestration. This image is a geologic map of the area with additional data sets overlain on the bedrock geology. Drill core are shown by red dots, while mines, pits, and quarries are shown by green dots. 1980s vintage 2D seismic lines are shown in these gray lines. I have been collaborating with USGS scientists to interpret these seismic lines, and this ongoing effort will allow me to better link the geology under Lake Superior to the onshore geology known from drill core and outcrop. A specific goal of the STATEMAP project would be to subdivide the Frida Formation, that's this orange unit here. The Frida Formation is presently described as a kilometer-thick fluvial deposit. Here is a close-up of Bayfield County and the Frida Formation. Subdivision of this unit would show up on this map as additional polygons within the orange Frida Formation. Thanks again for your time, and I'll look forward to hearing your suggestions and feedback.